Hello, I'm Sam Bown, and this is Incident Response with Velociraptor. So I'm an instructor at City College San Francisco, and I do corporate consulting and training with InfoSec Decoded Incorporated, and I present at a lot of conferences like DEF CON and Black Hat, and the one you're at right now. Everything I'm going to show you is free and open source, and all the slides, like the ones I'm using now, and lecture videos and project instructions are all freely available at samsclass.info, so you can add any part of this to your class and freely use it however you like. So in incident response, the typical situation is you have a big company, you have a lot of computers in multiple locations, and you have a problem of some kind, like malware has infected a machine. Now what do you do? Well, you could just clean that one machine, but the problem is it might already have spread. It might be the first thing you've noticed about a large intrusion campaign that's been going on for a while. So you need to find the scope. You need to interrogate other machines to see how many other machines are infected also, and you need to examine the machine that you know to be infected to figure out how that infection got on there and what else might be going on there that's affecting our network. Now, you could infect that machine directly, but in a large network that's not practical, and that's why I love this tool, Velociraptor. This is a central server to perform incident response from one location. It is very powerful, and it's free and open source. It's like a domain controller for incident response. So in this one location on some central server, you can collect data from all your endpoints. You can run a hunt that will go interrogate all your endpoints, asking them for certain information, and then accumulate the information like email asynchronously from them, where the server is not frozen waiting for answers. Once you find some evidence and you determine your indicators of compromise, you'll now have more details with what to look for, certain file names, certain running processes, certain network connections, and so on, and you can write a script easily that will go collect that information from the endpoints that you wish to inspect. And I was very pleased to observe that this project was bought by Rapid7. Rapid7 is an excellent steward of open source projects like Metasploit. So if Rapid7 buys it, it will be turned into a great commercial tool, and they will maintain the free open source version as well, I expect. And the current version runs on Windows, Mac, or Linux. So this is great for teaching and great for using in the real world. So it has a simple executable. Use the same executable on the server and the client. So you can install it on a Linux server. Here it is running on a headless Linux server. It just runs a little web server to give you a web page to manage it. And you install a Windows client on your Windows machines or whatever other machines you want to monitor, and then you'll just control it from this web interface from anywhere you want to be. So here you see a Velociraptor server connected to a client, and this client is running Windows 10. All right. So let's run Velociraptor and collect some artifacts. So I'll start with my Windows machine here. This is a Windows 11 machine, and I've installed the Velociraptor client. It's just an executable. You run it with service install as parameters in an administrator command prompt, and it installs, as you see it here, as a running service in the background. So this is now connecting to the Velociraptor server and responding to requests from the Velociraptor server. Here's my Velociraptor administration page, just a web page, going to my Linux server, and here's the home page of Velociraptor. If I click Show All, it'll show me my clients, and I have only one client, my Windows 11 machine, which is being misidentified as Windows 10 actually, but nothing's ever perfect. Anyway, I click on the blue link to see details of that one machine, and I click Collected. I can now collect information from that machine. If I hit the plus sign, I see a directory of all the artifacts that it can pull off of that machine, and there are a lot of pre-made artifacts that will ask your machine for anything you want Linux, Debian, or Windows. If I go down to Windows, you can get the Chrome history, the prefetch folder, many, many other things. So let's start with something simple, netstat. Just search for netstat, and here's the Windows netstat command. Here it explains you what it is. It will just execute the netstat command and send you the answer, so you launch. And click that row up here, and it's done already. Here are the results, just a list of IP addresses, running processes, and the ports they've made connections on. Here's the Velociraptor client, which has made an established connection to port 8000 on my Linux server. That's what it does. It connects from the Windows machine to port 8000 on the server, and that's how it's sending the commands to request this sort of information. If you run the enhanced netstat, you get even more information. All right, let's run that one. And you see it's still running with the hourglass here. You can go to the log and watch it run. Starting query execution. It's still running. Now it's done after 8 seconds, and it got 53 rows of results, which I can see here. And now, in addition to seeing the name of the executable, I see the path to it, and I see hash values, and I see authenticode signatures, which are extremely useful. I can now tell if a product is signed by a legitimate company. Like this is signed by Windows, Microsoft Windows, issuer name, subject name, Microsoft. This is also signed. This is also, here's Velociraptor, and it's also signed by someone in by Sectigo, Velocidex. So anyway, you can tell if something is signed by a known company, and that means you can trust it, or if it's an unsigned executable, which is more suspicious. So let me go back to my slides. And for the next demonstration, I'm going to inspect a Windows machine that is infected with a simple piece of malware I wrote. And all this malware does is pop up an irritating box saying your machine is pwned. And we're going to try a variety of artifacts here to learn about what process is making this box pop up. All right, so here's a Windows 11 machine, and it's infected by malware. So every time you restart it, it puts up this irritating message, and this message contains the word pwned, which is a useful thing we can use to hunt for the cause of this. So here in Velociraptor, now the first thing we can do is find out why something would launch automatically. So we run auto runs, which is a Microsoft tool from sysinternals, and this will automatically download that tool onto the machine and run it. So I launch that, and here you see it's going. It removed some temporary file, it downloaded something, and here, yeah, it downloaded auto runs, and now it's running it with the some command line parameters to just search for all the automatically launched processes, and it's done. It found 1,449 automatically launched processes. And here they are. And as you can see, there's a lot of them, and this would be pretty annoying to read through in this interface. So what you can do is you can download it in various formats. This will download it as a CSV right here in my browser. And you can open that CSV in a spreadsheet, which is what I've done here. And when you do, we go to the top, you'll see that I have a lot of information here. I've got the, this is why it's launching. This particular one is in the registry in the current control set services. And here I have a description, and here I have a company. And this is the company that signed this code. And remember, like I said before, you can use this to tell malware from good stuff. So I just sorted by company. And that takes these 1,400 items and it puts the ones with no signatures grouped together at the bottom. And as I just looked through them, one of them is obviously suspicious. See pup4message.exe. And I can see that it's here in a run key, which is a key that will run software every time you restart the machine, and it's in the WASTC node, which means this is 32-bit code running on my 64-bit Windows 11, which is also kind of suspicious. So I suspect that this process is causing that message to pop up, but I haven't really proven it yet. I need to know more about that process. So I can learn more about it by going to PS list. All right. This will list processes and their running binaries, so it's not really going to give me a whole lot more information than what I already have, but let's take a look and see how it works. You can list all the processes, or you can just give a string. I'll put in pup to only show me processes that contain the word pup. Launch that. It's already done. And here it is, pup4message. Now I have the hash. I could take this hash and send it off to a company like VirusTotal to see if this is known malware. And here's the authentic code information showing that this is unsigned software. Nobody has vouched for it. So it continues to be suspicious, but I haven't yet proven that it's responsible for that message. What I'd like to do is see the memory used by this process. So I go to make a new collection of memory, and I go to Windows Triage Process Memory. This will dump process memory and upload it to the server, which is just what I want. So I go here in parameters, and it's by default it's going to look for Notepad. I don't want Notepad, I want pup, something with pup in the name. Launch. And here's the log showing it's running. All right, it's done. If I go to results, there's just the same kind of information it did before, the hash values, although this is now telling me about the dump instead of the process, and the dump is here in uploaded files. And if you click this, it will just download it in the browser, and then you can open it in any tool you like. And what I did was just open it in a raw hex viewer that I've got. So here's that dump, starting with MDMP, and then you see it's just got some readable strings about Pacific Standard Time and so on. Notice that these strings are not ASCII strings. These are Microsoft Unicode strings. So after each ASCII value, there's a null byte, and another null byte, the way Microsoft generally stores strings to meet their old-fashioned Unicode system. So I can search, and I need to drag this down to see the fine pane. And so if I search for pwned here, search for next, it's not going to be found, but that's because it's not stored as ASCII. I need to go to hex, and now I need to add a null byte in between. So after each ASCII value comes a null byte. And now when I search, here I find your machine is pwned, and if I keep going, your computer is pwned by double bad. So now I know this running process called pup4message is in fact the message that's creating that irritating pop-up box. Now the next question is, what other executables in this box are involved? Is it just that one executable, or is it more? And for that, we can use Yara. Yara is a very powerful tool, very simple tool, commonly used in incident response. It just searches for a pattern of bytes in a file. So I can go to Configure Parameters, and I can specify what to search from. Now, by default, it's going to search for DIL files in kernel 32, and that's not what I want to do. I want to search for exe files, and I want to search for them anywhere. So I get rid of the path information. The C drive is fine. I could restrict it to only look for files changed recently, but I'm not going to bother. Now, you can put in a Yara rule in the official Yara language here, in this multi-line thing, which is fine, but I don't need to do that for such a simple rule. I can use this shorthand Yara, which is wide, pwned. That will just look for the word pwned in Microsoft 16-bit Unicode. So I can launch this, select it up here, and look at the log to see what's happening. And it did understand my rule. It was able to compile this wide pwned. Here it is searching for things. One great thing about Yara is that if it cannot directly open a file, it cannot open a file through the usual Windows Explorer system, it can then access the disk directly to open files that are in use and otherwise unavailable, and that's what it's doing here using the accessor. So it really will find every file on the hard drive and scan it, and that will take about a minute, but really that's not too long to look for through such a large amount of files. So we can see down here, it spent the first 30 seconds waiting for rows, and it'll only take about another 30 seconds to finish. Here it is, just more messages about the accessor. We're up to 60 seconds. There we go. And now it's done. After 1 minute 33 seconds, it found one result. And if we go back to the top, we can look at that result. There is only one file containing that string on the drive. It is this C pup4message.exe. So all the rest are gone. And we have figured out, without going anywhere near the box or remote location, we have figured out a lot of information about the infection, and now we know the file that's causing the problem. So that's it for that one, and let's move on to the next one. This one here is a bot. It's infected by remote control software, so the machine is beaconing home to a command and control server. And so to analyze this one, we're going to do a remote network packet capture that will collect the network traffic from that Windows client. And this uses a built-in Windows tool called ETL, which is surprising to me. I didn't know this. Microsoft includes a tool which will collect network traffic in a strange format. And Velociraptor will convert it into a normal PCAP we can open in Wireshark. And we can look at the DNS cache and task scheduler. All right, so here's my Windows machine, and you saw a little pop-up there. It's infected by a bot which is sending periodic network traffic home. There isn't any obvious persistent pop-up or anything, but we can analyze this one too with Velociraptor. So we can start by capturing the network traffic. So here we are, Windows Network Packet Capture, and here it explains to you how it works. You have to run this artifact twice, first to start the capture and then to stop it. So first you run it with no parameters at all, and that begins the capture. And if you look at the results, it's done already. And the results just give you the path to the capture file, which is an ETL file. And you need that path. Now here it is, 2231.58. I want to give it at least 30 seconds of capture time. So I don't want to launch the next one until 30 seconds after. But let's go to packet. All right. And configure parameters. And here, you don't start trace, but you paste in the trace file here. And then when the time comes, you run this one, and it will upload the files back on the machine. Now I'll give it a try now, because it doesn't matter what I want to I'm going to go back to my previous run of it. The histories of them are here, and just show you the results from there. So when it's done, it's going to upload files, a PCAP-NG ready for Wireshark, and the original ETL, which it got from the Microsoft system in whatever goofy format that is. And you can download that PCAP-NG file and open it in Wireshark. And I've done that. So here's the 71 packets that my machine sent off during that time period of capture. And if you go to Statistics, Conversations, you see that here's some traffic going to port 8000. That's the Velociraptor server, command and control. Here's a couple of very brief communications to port 443, sending just 0 bytes and 55 bytes. And here's the stuff that's suspicious, 377 bytes sent to something on port 80. So we can apply as a filter, selected, both directions, to see the suspicious traffic. And here it is, it's doing an HTTP GET. And if we follow the TCP stream, we can see that it is sending suspicious-looking traffic with a user agent of Mozilla spelled wrong, and this host, which is the domain name of the command and control center this bot is phoning home to, security-report.samsclass.info. So now we have a network indicator of compromise telling us when machines are infected because they have that string. Now, let's take a look at the DNS cache. Shouldn't be a surprise, but it's worth checking out. So the DNS cache is going to look for DNS resolutions on that machine. So we'll launch that. And here's the log. Okay, it's running ipconfig/display DNS. That's all it's doing. And here's the results, and there it is, resolving that domain name. By the way, I should mention, on some Windows 10 machines and this Windows 11 machine, I could not run ipconfig/display DNS until I switched it from automatic to manual addressing. So something is a little weird about the latest versions of Windows 10 and Windows 11 and their DNS resolution. But anyway, that's a workaround. So now I know that it's phoning home to this server. Now I would like to know what executables on the box refer to that string. So here we can use the same thing we used before, Yara. Detection, Yara, NTFS. And we don't want DILs, we want EXEs. And we don't want to just look in that folder. We want to look in all the files on the C drive. And we don't want this test rule here. What we want is to look for either ASCII or wide security report, which was part of that domain name. So that's it. We can launch that one. And that may take a little while, but Velociraptor is an asynchronous system. While we're waiting for that one to run, we can then launch another one, which is to look at scheduled tasks, which may be how it's, because it's popping up every 30 seconds or every minute, so that might be that it's just in a scheduled task. And we can launch that. Now both of these things are running. We can check the log to see, okay, it's working on doing that. The scheduled tasks is done. And here's the results. And you see some Microsoft Edge update, Google update, and there it is, securitytest.exe. Security script is the name of this task. There is a scheduled task launching that executable periodically. And here we'll find all the associated files when that thing is done. And I think, again, there will be just one file. Let's see what happens when I ran it last time. Yeah, just one file. In the downloads folder, cuser student download securitytest.exe is the only file that contains this string, security report, in either ASCII or Microsoft Unicode. All right. The last demonstration is the remote access Trojan here, where we're going to find out, it doesn't have this box, but we're going to look and find out how this machine has been placed under remote control. I've already installed Sysmon on it, which I did remotely through Velociraptor, and now I'm just going to run netstat, which we've done before, to just see what network connections are being made on this machine. And if I launch this, here are the results. And notice that there's a process named shellbind.exe that's listening on port 4444, which is very suspicious. That's the default for the Metasploit toolkit. So, to find out when that process was launched, we can look at the prefetch folder. The prefetch folder keeps track of what's been launched recently on this machine. So this is going to give me everything, and there's 258 of them, so that's no fun. So let's limit it. Prefetch, Windows Forensics prefetch, configure parameters, and here I can give it a binary regex, and I can put in the name of the executable, shellbind. Got to spell it correctly though. All right, and launch that. And now didn't get anything. That's weird. All right, well anyway, something's gone wrong here, but let's look at the one I did before when I was practicing it. And here I got my one result, and it showed me exactly when this thing was launched. And it may be that it's been too long since I launched it. Anyway, this gives me the exact time when it was launched of 22:42 UTC today. And the last thing I can do is load Windows event logs. Now that I've added the Sysmon program to my Windows machine, it's making very good event logs for instant response. And you can fetch them with the event log Velociraptor acquisition here. So I can go to parameters, and here I was able to limit it to just the right time by using the start date and end date here. I was able to restrict it to just the right time, 1 minute before when prefetch told me it was launched, to 1 minute after. And when I ran that, that was my EVTX here, and I still got 489 results. So it's still kind of annoying to read through them in this interface, and I just downloaded them and put them in a spreadsheet again, and here are the results. And now I can search for the name of my file, which is shellbind. And when I search for it, I find here the PowerShell commands that launched that shell. Make a directory, shellbind, execution bypass. This is what tells the Windows Defender to ignore contents in that directory. And there were more commands here that unzip that stuff using from a 7-zip file and then launch it. So you can reproduce the entire path of the infection remotely, and Sysmon is another of the very powerful tools for incident response. So that's what I wanted to show you.